Hello, everyone. My name is Ilona Gabinsky, and I'm with Aviz Networks. And I'm thrilled today to introduce you to the exciting world of Aviz and our innovative solutions. Joining me today is Chit Perumal, our Chief Technology Officer, who will give you a technical deep dive of one of our flagship products. And we are very excited to welcome Atsu Sen, Director of CTC America, who will talk about how this product is adopted in major telecom providers in Japan. So let me start with the presentation now. As we all see it in the market, AI is definitely redefining the infrastructure. Applications are becoming more GPU dependent, and they crave more data while driving networks to be faster and more robust. And AI and ML is definitely driving the productivity. So when we talk about networks, we see them in two main aspects. First aspect is making the networks for AI, and the second aspect is running the networks with AI. So making the networks for AI, it could be data center networks, edge networks, or GPU networks. And running the networks with AI, it includes such solutions as network operations, network visibility, and near network applications and tools. But the problem is that major networks are trapped in the vendor silo technologies and lack that innovation and flexibility, and also results in poor cross-vendor integration and very expensive upgrades. So let me show you how we are solving this problem. But first of all, let me introduce what Aviz is really quick and what we do. So we were founded as a company in 2019. We are currently present in 3 countries. We have operations in US, India, and Japan. Fortune 500 customers trust us, and we have the industry-wide validation and support with our partners, such as Cisco, NVIDIA, Wistron, EdgeCore, and others. So the main value we deliver to our customers is we deliver choices, control, savings, and all of it with AI. And let me show you how we do that. We help our customers build networks for AI and integrate AI into networks with our AI networking stack. So let me tell you a little bit what AI networking stack really entails. So it's been built from bottom up. And let me start here. First, so we have sonic solutions and non-sonic solutions. So first of all, what does it mean really being vendor agnostic? Imagine Linux for a minute. Does it really matter whether you use it on Dell, HP, Lenovo, or Google Cloud, Azure, or AWS? And this is the same freedom we are bringing to networking together with our partners and great support of Sonic community. So now let me switch gears to our products. First, we have WANS, which is a network operations product and provides such capabilities as orchestration, observability, anomaly detection and alerts, and AI fabric functionality such as Rocky. So this is our network-aware stack. To the right, we have network visibility solutions such as Packet Broker and Aviz Service Nodes. So these are 3 products that provide network-aware data and application-aware data. And because we have the data, we developed a customer-defined, vendor-agnostic data lake that empowers our LLM-based network copilot. So this is the stack, full AI networking, end-to-end data-centric stack with all our main products. And today, Chit will give you a deep dive of one of our flagship products, which is Service Nodes. And with that, I'll give it over to Chit.
Okay, thank you, Ilona. So I'll just do a quick recap. I think today we will be discussing about our network visibility solution, which is our Packet Broker solution, which includes 2 products: a Packet Broker network operating system, which is supported on switches, commodity switches running Broadcom and NVIDIA, supporting from 1 to 400 gig. And then we have our service nodes, which is appliance, which can be run on any commodity server, supporting Intel NICs and also NVIDIA ConnectX 7X for the packet acceleration. Right, and we will go in detail on the service nodes today about the overall solution and the internal architecture and a patented idea, which is patent pending idea, how we are able to achieve this performance for the telco, and go over and also how we have integrated that with AI with the data what we have collected from the service nodes. That's what you will see with a couple of demo videos. So this is the complete end-to-end solution of our deep observability solution, right? What we have. So for any network, whether it is data center or telco, you needs to have a packet monitoring fabric, right? That's one of the things. So that is where all your tabs and spans. It can be virtual tabs, or it can be physical tabs, or it can be a simple ER span pushing the monitoring traffic into your packet monitoring fabric. That's where our first product, Open Packet Broker Node, comes in, where we have solutions for the aggregation and the distribution layer. Aggregation layer is pretty much reduces the noise by eliminating some of the unwanted traffic, and distribution does advanced processing for deep packet inspection, which if the ASIC is capable of doing it, right? And we have supported for 1 to 400 gig, supporting both Broadcom and NVIDIA based solutions switches, and it is deployed at multiple customer sites, and this is independent of supporting both telco and data centers. Well, then we go on to the service nodes, which is the key of interest today, where you want to do advanced processing, basically deep packet inspection, and which includes looking at what is really inside the wire, like what kind of applications you are doing. That's the packet analytics, like dissecting the packet to understand what is happening. Second thing is, if you want to eliminate duplication towards the monitoring tools. For example, you put physical tabs, same traffic can be captured, and you want to eliminate the duplicate so that you want to send the right information to the tools for security and other analysis. And also focusing on telco, we have the correlation done for the 4G and 5G networks. Basically, when we say 4G and 5G network, it includes both control plane and user plane. Basically, we do correlation up with the telco traffic coming in, which includes the subscriber information along with the application, what they're looking at it, and calculate the KPIs for their network performance. Basically, it will be packet loss or latency happening in the network. Those kind of features are available in our service nodes. And the scale out analytics node is a pure analytics node where you can visualize the behavior of your network. Basically, you look at the 5-tuple information we extracted, how they are performing, what are the top talkers in your network. Those kind of information can be visualized using our analytics node. The outcome of this too is actually a metadata. That is what is what you get, right? You send out the information in a simplified metadata format, which can be a simple JSON or can be a Google protobuf or anything, which is fed to a data lake, which is powering our network copilot. And when we say this data comes from a very deep inspection of the packet. It is not like, okay, you have a BGP or a link down session, which is operational data, but more than that, it gives you what kind of applications you are running, and of course, not what is that, without compromising the security, that we don't expose the information which are secure to the particular network or anything, but gives you measuring those that data is pushed into a data lake, which on top of which our network copilot is powered. And by the way, we have the reason we have put NVIDIA Morpheus provides a very nice pipeline for doing there are a lot of open source models in Morpheus. We started integrating with Morpheus to see what are the use cases we can build. So we have integrated with NVIDIA Morpheus, where we will show a demo, a network copilot with an organic product, which also solves similar use cases on top of it. Right. So this is the high-level architecture of our Aviz service node for a mobile core. So this architecture is a patent pending idea from Aviz, where we have improved the performance for 5G by correlating the traffic between the control plane and user plane. There's like 5G has you see at the bottom, you see the actual packet which comes, which has to be, and then we have to extract the control session data, and then We also need to get the user session data, and then you need to correlate these two to provide the right information. Basically, what kind of tunnel endpoint it is hitting, what kind of cell tower it is in, what type of interface, whether it is N11 or N12 or PFCP, and what kind of direction it is going towards, uplink or downlink, and then which is the network, mobile network it is using, and then finally, using this correlated information, you can extract and measure the KPI of your performance for any 5G networks, right? So the thought process here is you will get a lot of packets. Basically, our service nodes can handle around 180 Gbps with this architecture, where we have a load balancer which will distribute the loads across different cores. Right, and this is, by the way, this is not a small server. It will be a server with at least minimum 100 cores if you want to go up to 180 Gbps, right? And it is powered by the packet processing is powered by Intel DPDK, and also supporting both NICs from Intel E810 and also NVIDIA ConnectX families, right? So what it model does, for each core has separate threads, and each of them operates in parallel, and the load balancers make sure that a particular control session and user session goes to the same core, so that you don't lose the symmetric correlation of the data, right? So first step is we decapsulate the packet, we pre-process the packet depending upon the type of the packet, whether it is a request packet or a response packet, and the control information stored into local database, which is inbuilt. And then we go on to the next level, where we identify the metadata, which is what kind of application, whether it is Zoom or Facebook or Skype, or what kind of application which is running, what the user is trying to do. When we have this information, we can correlate the information. Basically, when the session started, you logged into Zoom. Okay, the session started specific time, and you moved, you are driving or you are moving across different towers. You can measure how the performance is there for each of the applications. That's where the correlation happens, which is for a particular session. Once we have done the correlation, we get the actual metadata, which is exported to our customers. They use it for their own. For example, one of our major telco providers, they measure the performance of their telco networks using this data, and that is exported via a Kafka endpoint. And similarly, the same thing is pushed to our data lake as well for running LLM on top of it. That's another thing. And the bottom, you see, this is the data extracted. I try to put it from the packet. What are the information we extract, right? And most of them are telco, very telco specific. For example, N11 provides the interface between the SMF and EMF, basically the session management function and the user and mobility management function. Then user data is very clear, because that is a typical 5-tuple providing both inner and outer head information of the packet, Ethernet packet, and then the application info, which is like your DNS record or your HTTP record, and the actual traffic, how many bytes or how much of the latency, how many bytes are transferred and everything. And at the last, you have the correlated information, which includes both the packet and also the subscriber information per subscriber. So this information is captured per subscriber, because that's very important, because otherwise you will not be able to measure the KPIs for the whole session.
To better deliver network slicing? What is it making better for the?
Yes, for the mobile operators, this functionality is for the mobile core. It is not for the FTTH part. It is a mobile core. Say they will be able to see how they are offering the services to the FTTH customers, to the end customers, like network performance, and is there any latency when there is a change, and when there is a movement in the towers or tunnel endpoints are changed, that kind of things. And also they can, for security purposes, they can see where a particular application has been accessed. They can do the correlation and find out what is happening. So a lot of use cases there.
Good to see the app awareness.
Yes. So these are the top 4 capabilities of this service node, which is we have. And by the way, as we speak, it is getting deployed in one of the customer sites right now. The first one is the specific to telco, where we can correlate between GTP control and user plane sessions for both 5G and 5G NSA. NSA is non-standard request. When we say the key thing about this telco 4G, 5G is, even though there is a specific standard like BGP and everything, but a lot of people have their own vendor headers and vendor proprietary information. So it requires a lot of interfaces to be supported. Ericsson has their own, Samsung has their own, and it's very specific to the provider as such, right? So that's where the challenges will be, and we were able to do it across multi-vendor, because that's one of the unique proposition we can do it. Second thing is we are able to do a perfect mobile handover. Basically, when you switch from one tower to another, that's how the handover sessions. Basically, can you measure when the mobile handover happens from one cell tower to another tower? How to measure the performance? That and that is very important because that will measure your how your service is. Like we will always say, T-Mobile is not right, AT&T is not catching up in some of the areas. So that's one of the things KPIs which can measure. Application identification is more towards the IT ops and security because you can see deep in what they are looking at, what kind of data. I'll show in the demo how much of that in-depth information we can see, which provides a detailed information of what is being transferred without the payload, right? Like if you do HTTP GET, the cookies and everything, where you can identify DDoS, you can also do a behavioral analysis of what kind of traffic is going in your network, right? And finally, it's a standard. We have a unified fabric manager, which is for the orchestration purpose, which also provides the visibility of the whole solution, but also providing the clustering of 180 Gbps is one node, but if you have more than that, we need to have a HA inbuilt in it. We are supporting it, and also we can horizontally scale as the capacity grows. So that's where this management and HA capabilities come in. Demo of this.
May I ask a quick question while you're doing that?
Sure.
So, your customer base then is cellular telcos. Would this be also appropriate for people doing private cellular?
The service node provides three capabilities. One is telco specific for the mobile core, which is for the telco providers. Second thing is data center capabilities, which they use the packet deduplication and the application analytics. That is for thing. And third one is for the security ops people. So we have three. We have two customers who are already using it. One from the data center and one from the telco. Telco we have multiple, by the way, but these are the two. So it can be used for a non-telco specific providers as well. Does that make sense?
Okay. So like a private company who's doing their own cellular network, like within a campus.
Yes, absolutely. Because all we are looking for is the data traffic from the tabs, and then we can do the analysis on top of it. Absolutely. This is a lab setup. Yeah, this is what I was mentioning. So this is the control session data, gives you overview of, okay, how much of the information, like when is your session created, when you are trying to reach out, and when is the last seen, and these are some of the IMEI is your mobile phone. So these are like simulated information, not like real information, by the way. We cannot show it. And it gives you which region and pretty much gives you when the session was originated, right? Then we go into the user session, which gives you much detailed information, like all the Ethernet header. This is a standard thing which you can recognize, the Ethernet header. Then you can see the correlated information that, okay, particular mobile network is taking a traffic direction towards uplink, and they have the following endpoint, it is Japan. And finally, you extract the payload, what kind of payload you're looking at it. So this gives you an end-to-end visibility of what is happening when you just open a Zoom call in your mobile phone, and what that will give you the information. So this shows a small demo of how we have where we are creating, saying that this is a Zoom. And see, we are able to measure the latency and the packet loss and how much is the uplink latency and everything. Now we are sending the user sessions. So you see that, okay, we are able to get how much is the average bandwidth utilized for this user session, and average bandwidth at the bottom, you can see that. And finally, this is the actual thing, how you want to see. Basically, the various application you can identify how much of your network, where it is, and what are the applications being monitored in network pretty much. So this is, we have, by the way, they have integrated with Grafana because Kibana, because there were a lot of customers who were saying that, okay, can you just make it with Kibana because we are used to that. This is an integration which we have done for customers, saying that, okay, if they have an existing dashboard or existing monitoring or visualization tool, we can integrate with that as well. But it is also supported in our own thing. Yeah, this gives you how much of the data we have extracted. Okay.
So just one question there on now that you've extracted that data, you've analyzed it, and you're obviously generating reports and data out to the customer. What's the what's the next step now? I have this information. Where am I using it?
Yes. So two things, right? One is we are giving to the customer. They are using it for their IT operations to measure the network performance, how their network is performing. That is one of their use case. But our use case, we are looking at it is like we can use it for anomaly detection, saying that okay, if there is high latency observed in it, there is something wrong. Either one of your cell tower or the connectivity, the backend infrastructure is down. And second, one thing, so that is one of the things, anomaly detection. Second thing is the security purposes. What kind of applications they are running. So these are some of the use cases which we are planning to do or using Network Copilot, basically use the data. But customers have their own way of doing things. Some use for IT ops, for example, the telco customer, they use for IT operations and not for the network performance. Those are the use cases.
Okay, so if these anomalies are detected, there's a way for me to hit your application with an API so that I can surface those to the NOC that a latency problem is occurring.
One of the real use cases I will tell you which is happening right now. We were putting it on a commercial live deployment. The correlation percentage was only 5%. Basically, there were a lot of traffic, around 60 Gbps of traffic happened, but the correlation was only 5%. What we observed was there was a lot of attacks on using the GTP request, C request. There was no response coming. So that was one of the use cases. Then once we figured out where the problem was, there was a node which was not forwarding the response. Once we fixed that, so they were able to see the correlation happening for more than 60%. So they can see that. So those are some of the use cases which we can, which the NOC can, because it is not controlled. This is separate network which is maintained by the NOC, by the telco provider. So they use that.
So is this typically used in a proactive way where you surface those anomalies to be investigated, or in a reactive way where a ticket's come in and they're using this data to investigate?
So two things. One is reactive way, something on NetOps on demand basis where they see that okay, something has gone wrong, there is an outage happening. So they would like to see. That is the reactive way. But based on the historical data, they can measure the performance. Like they said that okay, the peak times is around this time. So based on the historical data, they can figure out like what happened in the past and how they can avoid as well. That is also doable, both ways.
Yeah.
So this, with a lot of information, what we did is we started saying that, okay, how can we apply AI on top of this service node, right? That's one of the things which we started thinking. And one we found is NVIDIA has this very nice Morpheus data pipeline, which has a lot of models, because there is a model called digital fingerprint model, which can be used for detecting anomalies in the data what you provide. It can be any data. We started using that. So what we did is first we collected the information ASN, the subscriber data from ASN, and we converted to a format which can be ingested into the pipeline. That's the pre-processing which we did. And then we trained the DFP model to process this data. By the way, when we trained the model to make sure that, okay, we gave a sample set of this data, what we have from the ASN, and pre-trained this model. And finally, then we put some actual data to see how it is detecting the anomalies, and we were able to get some good results on it. I'll show you a video. You see here, these are on the top, you see this MLflow server where we have the trained model in place. And DFP Morpheus is the pipeline, and Grafana is something which we use to visualize this content, how we can run. These are all microservices running on a physical NVIDIA hardware. We have a Tesla V100 GPUs running in this is in our lab, by the way. So we were, it's like, okay, we want to try it in our local on-prem, because not run on the cloud or anything. Since the training is done, so we see training users is none here because it's a trained mod already. So we are just pushing with the raw data. And this is where we are pushing the raw data into the pipeline. And once it is done, you get, we exported data to the Grafana. So one of the few things I was mentioning here is, on the top here, you see, these are the anomalies. You see the top red, these are the anomalies. What the DFP model in Morpheus says is, okay, they call it a Z-score. They measure it as a Z-score. When they say an anomaly, the Z-score is very high. Basically, it will tell that, okay, when there is a higher Z-score, then there is an anomaly. So for example, here, the retransmission count is high. It can be because of any reason. It can be TCP failure or a network failure, or it can be some device down, right? So it will give you, upon the data what we have provided, able to detect that there is a retransmission failure in your network, right? This is like, it is not even reactive. You are continuously monitoring a network, and you are able to see that. Similarly, when there is a null here, right? What it means is you're not able to correlate. There is a lot of requests coming, there is no response coming. So basically, you are getting into a situation where that, okay, there is something wrong in your network because all your GTP-C requests are coming, but there is no response to correlate it. So these are some of the anomalies. And what metrics data set it uses? These are the metric data set which is coming from our ASN. So the data comes from our ASN, and the model is able to quickly run through it. By the way, this came very fast. It is not like we took a lot of time. We just fed this to the model. The model was already pre-trained with the data, and we were able to execute it on top of it. So this model can be run on top of our Network Copilot, because Network Copilot, what we do is we don't have a model our way. We just use the existing models which are available, open source models like Mistral, Llama, and similar to DFP, and then we train and fine tune with our use case or our data. That's what we did. Right, and this is one classic examples where we want to tie this deep observability into AI, where because AI is all about data, right? It is not that, okay, you provide the right data and tell the problem, then you are trying to solve it on top of it. So that's the thought process here. So that's